What was the last topic? So you are seeing example exercise problem. So 2.7 was the last problem, right? Shall we move on to the next one? So what is the next question? Can you tell me 2.8? What is the page number? 86. Guys, those who are online, are you able to hear me? Those who are online, are you able to hear me?
Yes, sir.
Okay. Yeah. So can you tell me the question 2.8? They read, someone read the question, no?
Parallel plate capacitor are between plates. Each plate has an area 6 into 10 to the power minus 3 meters square.
Okay, 1 minute. So there is a parallel plate capacitor, and each plate has an area of how much value?
6 into 10 to the power minus 3
6 into 10 power minus 3 meters square. Okay, and in between medium is there.
Yes.
Okay.
And then the distance between the plates is 3 m.
The distance between the plates is 3 millimeters. So 3 into 10 power minus 3 meters. Right.
Calculate the capacitance of the capacitor.
Okay.
If the capacitor is connected to a 100 volt supply, what is the charge on each plate of the capacitor?
Okay. So first, they're asking what is the capacitance. Q is equal to what and P is equal to 100 volt. Correct? Okay. So how to calculate the capacitance? C is equal to epsilon naught A divided by D. So epsilon naught A divided by D, which is 8.85 into 10 power minus 12 into what is the area? 6 into 10 power minus 3 divided by D. D is 3 into 10 power minus 3. 10 power minus 3, 10 power minus 3, 1, right? Answer will be 70.7 into 10 power minus 12 farad, or I can write 17.7 picofarad, right? So 17.7 picofarad is also an accepted value, right? So what is the next part of the question? They are asking charge on each plate. So charge on each plate is the charge stored as this capacitor also. So Q is equal to how much? Q is equal to CV, it's already known. 17.7 into 10 power minus 12 into voltage is 100, which is going to be 17.7 into 10 power minus 10. So this is the amount of charge that is going to get. Is it clear? This. So let's go to the next. 2.9.
Explain what would happen if the capacitor given in exercise 2.8, the 3 millimeter thick mica sheet of dielectric constant 6 were inserted between the plates.
Okay, thickness of the mica sheet is 3 millimeter.
Yes.
That is 3 into 10 power minus 3 meter. Okay. Is inserted between the
First, first one, while the voltage supply remained connected,
okay.
each after the supply was disconnected.
Okay. So P is equal to how much? Listen. See, before this, I need to teach you a concept which is not there in the textbook. So I want you all to write down this. So before I solve this, we'll prepare a table of what will happen when dielectric is inserted with the battery connector and disconnected. Okay, I repeat, you will not find it in textbook. So please make a note of it. But questions are asked based on this. Okay. Capacitors with dielectric. Okay. So capacitors with dielectric. There are two scenarios you are going to draw. With battery connected and with battery disconnected. I think that is a question, right? So first part is connected, second part is disconnected. Right. So if I say this is the point to be noted, let's say initial capacitance, then charge, voltage, energy, and what else can I talk about? Electric are and electric field are C naught, U naught, V naught, U naught, and E naught, respectively. Okay, this is the first point to be noted. Make a note of this. So what I'm trying to say is, even before you inserted the dielectric in between the plates of the capacitor, let's say the initial value of capacitance, charge, voltage, energy, and electric field are C naught, Q naught, V naught, U naught, E naught, respectively. Okay. So with this in mind, we will try to calculate what will happen to the final values when dielectric is inserted. Okay, let's say the dielectric has a dielectric constant. Dielectric constant is K. So if I say dielectric constant is K, then we know the fact what will happen to the new capacitance when dielectric is completely inserted. So here when I say capacitance with dielectric, it is completely inserted. That is the point you need to make up. Okay, what will be the value of C dash? It will become K times C naught. And what do you think will happen here? C dash will be same K into C naught because the capacitance is the property of that material. So it is going to get multiplied whether you connect a battery or disconnect. Because this is a device that you are going to go and buy it from the shop. It has nothing to do with whether you are connecting a battery or not. Its capacitance is fixed, like how you get a water bottle. Its capacity is fixed. Similarly, capacitance is fixed. Is it clear? So this is the first point to be noted. So in both the cases, it is the same. So I hope you got the answer for 2.9 first question. What did they say? When battery is connected or something they gave, no? So when you talk about the capacitance, it is independent of whether you connect a battery or not. Okay. Now what are the parameters that are going to get changed? Is what we will see. Okay, listen to this carefully. If I say initial voltage is V naught. Okay, if I say the initial voltage is V naught, then V dash will be equal to, means there is a capacitor. Inside the capacitor, now what is present? Dielectric is present, and what have you done? You have connected the battery. When you connect the battery and keep it, the V dash, that is a new potential difference of arising across the terminals of the battery, will still be V naught. Why is it so? Because the battery is still existing. It is continuously supplying energy. Whereas you insert a dielectric and remove the battery, right? The potential difference will no more be V naught. Rather, it will drop by a factor of dielectric constant. So it will become V naught by K. Is this clear? So these two data is enough for us to calculate the other parameters. Okay, now what is the relation between Q, C and V? Q is equal to C dash into V dash. So can I say Q dash is equal to C dash into V dash? That what is C dash is? K times C naught into V dash is V naught. Correct? So what is happening here? So this will become K times C naught V naught. Meaning what is actually C naught V naught? C naught V naught would have been Q naught. So what is happening to the charge now? The charge is increasing by a factor of Q naught. That is logically right only. No? Right? When you insert a dielectric and still keep supplying energy, what will it do? It will be able to store more amount of charge compared to the previous scenario. It is doing. Okay. Then what about the charge when the battery is disconnected? Means you have a capacitor dielectric inserted. Now, what is going to be the value of Q dash? Same C dash into V dash.
Q naught.
This time it's going to be K times C naught into V naught divided by K. K is going to get cancelled. It will be C naught into V naught. This is Q naught. So what is happening? Charge drops to its original value. Original value of what was there before you inserted the dielectric. Is that clear? And why would it obvious? Why would it happen? Why would this happen in the first place? So when there is constant supply of charge rate, it is similar to your mobile phone. For example, let's say you have charged at 100%. Okay, you are still connected to the charger and you are using it. Let's say you are playing game for half an hour. Will the charge decrease? No, right? So it is going to be stable. As soon as you disconnect it, what will happen? Whatever charge was there in the battery starts dropping. Right? You want water? You're fine. You have water. You're fine, or you want to go? Fine. Here guys, so it starts dropping and it goes back to its original value. Right? What about the energy now? Can I say U dash is the energy? What is the formula for U dash or U? Half C V square. Or half C V square. Half C dash V dash square. Right? So this will be equal to half into what is C dash now? K times C naught. What is V dash? V naught. So it will become half into K into C naught V naught square. But what is C naught V naught square by 2? C naught V naught square divided by 2 will be U naught. So what is happening to the energy now? It becomes K times U naught. Then what about this parameter? So U dash is equal to half into C dash V dash square. So half into C dash is K times C naught and V dash is V naught by K the whole square. So this, if you try to calculate, you will get U naught divided by K. Okay. So you can calculate and see you get U naught by K. And lastly, shall we finish the electric field also? So new electric field E dash will be equal to, what is the relation between electric field, potential difference and distance? E is equal to V by D, right? So can I write this as V dash divided by D? The distance is not changing, but what is V dash? V naught by D. So if you see V naught by D is nothing but the original value. So the electric field will be E naught, whereas in this case it becomes E naught by K by using the same logic. Is that clear, guys? Yes. So there is a very, very important table. I think in 2018, I think they asked a question which is based on response. 3 marks question you can, there is a possibility of you getting. You would study the whole chapter, suddenly they will ask you this, which is not a part of text, but it is still taken under consideration. Okay, they will not award marks for you if you go better. You have to better learn it. Okay. Shall I proceed? Done? Okay, we solve the problem 2.9. It's very simple now. Yes. So, what is the 2.9? What would have happened to the capacitance in the dielectric material? Mica is there, right? Mica is a dielectric material. Okay. And what are the dielectric constants for it given? 6, right? So C dash will be equal to K times C naught. So what is the value of C naught we got in the previous case? 17.7 into 10 power minus 12. So 6 into 17.7 into 10 power minus 12. Accepted. So this is going to be the capacitance. What else did they ask? Something like disconnecting something they asked about. So they are asking about capacitance here. So I told you about capacitance. Whether you have battery connected or disconnected, it's the same value. Did they ask anything about charge? No. Right.
Guys, those who are online, any doubt? Is it clear?
Yes, sir.
Guys, those who are online, is it clear?
Yeah. Sir.
Okay.
Yeah. Okay, shall we proceed to the next one? I think 2 more problems are there. 2 or 3. So 2.12. So 2.10. What is the question? 1 minute. There is a capacitor of 12 picofarad. It's connected to a battery of 50 volt. Okay.
How much electrostatic energy is stored in it?
Okay, first let's do that. So how much is electrostatic energy stored in it? Half CV square. So half into C is how much? 12 into 10 power minus 12. So convert everything to standard units. Okay, 12 into 10 power minus 12 into what is the potential difference to P square? Correct? So this is going to be 6 into 2500 into 10 power minus 12. Okay. So how much will it be? 2 zeros will get cancelled. This will be 10. So 25 into 6 is 150. So 150 into 10 power minus 10. Or I can write it as 15 nano joule. Actually 15 into 10 power minus 9. Okay. Keep checking the answers. That answer. There is a mistake. Correct. So this is what they ask, no, when the battery is connected. Okay, what is the next part of it? That's it. Okay. 11th one. So what about the 11th one? Read the question. So there is a 600 picofarad capacitor which is
Charged by 200.
charged by 200 volt. Okay. 11th one, listen this. So you have a capacitor whose value is 600 picofarad. It is charged by a battery which supplies 400 volt. Accepted. 200. Okay. 200 volt.
It is then disconnected from the untitled. How much of the static energy is lost?
Okay. So read the question carefully. So initially, what is happening? You have a capacitor which is connected to a 200 volt potential source. By doing this, what is going to happen? When you do this, what is going to happen to it? Energy is going to get stored in this. So how much is the energy stored in it? Half CV square. So half into C is 600 into 10 power minus 12 into V square is 4 into 10 power 4. Accepted. Right. So this is going to go 300 times 1 2 plus this will give you 6. So 6 and this will get cancelled. So you will get 12 into 10 power minus 6. So this is the value. So initially this is the amount of energy stored in the first capacitor. See, though you connect it to a 200 volt supply, right, which is almost equal to the energy consumed by these fans, 220 volt generally. But if you see the energy stored is still very less value. Okay. Now with this energy, what are they going to do? So they connected. Now let's try to visualize this. So you have a capacitor. Now you are connecting it to another capacitor of the same value, correct? And here, what is happening? You don't have a battery. Now these two are connected. So when they are connected, what is going to happen? This positive charge, negative charge. Right? What will happen? So when you connect it to the other capacitor, like this, because you need a closed circuit, right? This will get the positive charge, this will get the negative charge. Because now this capacitor itself is acting like a battery. Now what will happen according to your knowledge? Will this still have the same amount of energy stored in it? Is it going to still be 12 into 10 power minus? First thing, what is going to happen?
Can we say the charge is equally shared?
Why? How can you say it equally? Just because they both are of same capacitance. What is their difference? How you handle it? We need to think about it, right? So in this problem, luckily you have 600 picofarad for both. Similarly, there is an example problem. There I think they would have given 900 picofarad. The last problem in this chapter. Okay. But if you see, when it is similar, yes, it is going to get equally distributed. What if they both are of different values? Then you need to know the logic, right? So initially, what is happening is the first capacitor which has got charge will have some amount of potential voltage across it. It will have some voltage, due to which it is also going to have some charge present on it, and it also has some energy. These are all interrelated parameters. It has some energy as well. Now, what is going to happen? Charges will start going from the capacitor which is charged to the uncharged capacitor. Now the question is it going to completely transfer its charge to the other one, or will there be a point at which the process will stop? Think about it. So there may, what I'm saying is, let's say initially its energy is some u. Will it completely become zero and it transfer all its energy to this one, or will there be a point where it will stop? It will stop, right? So where is it supposed to stop? When the potential of both these devices is the same. So this is similar to the flow of heat. So generally when you take a material, okay, so heat will start going from which temperature to which temperature? Higher to lower temperature. When will the process stop?
Temperature.
So when the temperature difference becomes zero, means they both are at the same temperature, right? So temperature and voltage are same. Temperature is with respect to heat flow and voltage is with respect to charge flow. Okay. So the logic is, when should it stop? When the potential of both the capacitors becomes the same. When same potential is attained, charge flow stops. Correct? Now, when this is going to happen, what is going to be the final charge present on both the devices? So let's say initially this has a charge Q. Okay. How much is the charge present here initially? 0. So at some instant, this flow has to stop. Correct? So when it is going to stop, what will be the charge on each capacitor at that instant when the potential becomes 0? This is the question that we, it becomes Q by 2, but I have to show it mathematically. I cannot say just because they are of same capacitance that is going to be. I need to derive a mathematical equation for both of them. Correct? For that, what we are going to use is, we will use the concept of conservation of charge. So what does it tell us? If you have an isolated system, right, the total charge present on the system is always a constant. So what is the initial total charge present on the system? Q plus 0, it is still Q. So initially the charge is Q, and finally what would be the charge present on it? Let's say the charge on the first capacitor is Q1 and the charge on the second capacitor is Q2, accepted. So this is the initial value, this is the final value, right? But how can I write Q in terms of capacitance and voltage? CV. So initially, can I write it as C1 V1, irrespective of whether it is same or different? I'm saying here the capacitance is V1, here the capacitance is C2. Correct? Can I write it as C1 V1? This will be equal to, how much will be the value here? The capacitance at that point will still be C1, accepted, because capacitance is independent of charge and potential difference. But what parameter will change? V will change, because they will start attaining a common potential at that instant when the process stops. So can I write the common potential as V? So C1V plus C2V. Correct? So this will be equal to C1 plus C2 into V. So what will be the common potential, guys? V will be equal to C1 V1 divided by C1 plus C2. So this is the common potential which is required for the system for the flow to stop. And this also have, see, at the second capacitor also had some charge initially. What should we write on the left hand side? C1 V1 plus C2 V2, because they both will be a different potential for the charges to go. But on the right hand side, what will you have? C1V plus C2V. Again, I repeat, this concept is not there in textbook. So the concept, this concept is actually called derivation for attaining common potential when the charged and uncharged capacitors are connected. So formula for what is it? What is this potential called as? Common potential. So this is the formula for common potential when a charged and uncharged capacitor are connected. Derivation for common potential when charged and uncharged capacitors are connected. So now can you find the common potential is using this formula for this problem? So what is the common potential? V will be equal to C1 was how much? 600. 600 into 10 power minus 12 into what was the value of V1? It's a 200 divided by C1 plus C2. So 600 plus 600 into 10 power minus 12. So 10 power minus 12, this will get cancelled. So you will have 600 into 200 divided by 1200. So what is going to happen is, so the final potential will be 100 volt. Okay. Now the final potential is 100 volt. Can you calculate the final energy of each capacitor? Can you calculate it? How much will it be? Half into C1 V1 square plus half into C2 V2 square. This is the final energy. This I call it as initial energy. So what is the final value is? Half into, see, remember C1 and C2 are same, V1 and V2 are also same. So can I write this as, in this scenario, can I write it as, wait, I made a mistake. What should I write? C1 V square and C2 V square, because they are having common potential, right? So half into, so C1 and C2 are of same value, so can I write it as C1 V square? So C1 V square, now how much will be the value? 600 into 10 power minus 12 into V square is 10 power 4. So this goes 8 times, 2 times. So 6 into 10 power minus 6. So how much is the energy loss? So see, initially the energy present on the system is 12 into 10 power minus 6. Finally, the energy, total energy present in the system is 6 into 10 power minus 6. Why is it not still 12 into 10 power minus 6? Because, so the wires are there, right? They are acting as a medium to take up the charge. So the energy is lost in the form of heat. So I want to do a small modification in this problem. Okay. So did you all copy this? Done, right? Okay. So they asked change in energy, right? Or did they ask what is the final energy?
Energy loss.
Energy lost is how much? 6 into 10 power minus 6. So that is what you need to do. Okay. Can you note this one? I want to make the change by the value. So let it be 600 picofarad and this be the value. The other capacitor C2, let us take it as 900 picofarad. Now calculate the energy loss at time. So till here it is the same. So there are two capacitors in this problem. 600 is first charged, and then it is connected from the disconnected from the power source and connected to a 900 picofarad capacitor. Now calculate what is the energy loss in this process. Good fast. Did anyone update the value for common potential? 8 here. potential is 80 volt. So what will be the final value of energy? U final will be half into 600 into 10 power minus 12 plus half into 900 into 10 power minus 12. This whole thing V square. But instead of writing half C1 V square with half C2 square, I took the V square common and I wrote it at the end. So how much will you get? 300, and this is going to be 450. So 300 plus 450, 750 into 10 power minus 12 into 80 square is 6,400. That's right. Here. So 10 power minus 10. So it will be 7.5 into 10 power minus 8 into 62. Calculate this value. How much is it? Is the logic clear? 960. See, what is 75 into 64? 480. So you are getting 480 into 10 power minus 8, or this will be 4.8 into 10 power minus 62. So what is the energy loss? 12 minus 4.8 is the energy that is lost. So wherever you see a question which is based on loss, it is always initial minus final. Okay, gain minus final minus initial. So we've added the loss. Clear? So I hope it's clear, right? Any of those? Clear. So we covered all the problems. Right. So that's all with this chapter. Okay. So I'll just give you a brief introduction for the next chapter as well. We'll go to the next one, that is current electricity. So write down the heading, chapter 3, current electricity. Okay. So if you see the first two chapters, what were they? They came under the branch of electrostatic. Means they were dealing with charges at rest. So what does this current electricity has to do? So here you are going to have the charges in motion. Current refers to flow and electricity refers to charges. So if you are able to talk about flow of charges, then that falls under the branch of physics called as current electricity. Right? So in this, what are all the parameters that we need to define? Right? What are all the I'll call it as basic terminologies that you're supposed to know. Okay, you see in this chapter is an extension of what you have learned in your 10th grade under the name electricity, chapter 12. Okay. So in those basic terminologies, the first thing that we need to know is about something called as electric current. Okay, the first term that we are going to see is electric current. See, when you dealt it in your 10th grade, right, you would have dealt only with one value. Now we'll be dealing with different values because you know some more mathematics, right? So when you talk about an electric current, what is going to be the basic definition for it? Yes. So you call something as rate of flow of charge through what? Through a given area of cross section. through a given area of cross section, you are able to calculate the number of charges that are flowing, and you divide it with the time for which those charges are flowing. Then you will get a parameter called as electric current. Right. So when you talk about electric current, generally what is the simple use for electric current? It is I. Some books use small I also. Okay. So when I write I, then how can I write it in terms of mathematical values? Write it as delta Q divided by delta T. Or you can just write it as Q by T. Some books refer to it as delta Q divided by delta T. Okay. And whenever you use delta, right, then the current you are trying to define is called as average current. Okay. So this is what is average current. Similarly, you have other type of current where you can write it as dq divided by dt, which you can call it as instantaneous current. You have to understand this. So this can be called as instantaneous current. Okay. Now the question is, what is going to be the SI unit code? So SI unit is coulomb per second. So coulomb per second can be called as ampere. And ampere represented by this simple capital A, the name of the scientist. Right? Now the next thing is, what is the type of physical quantity? Is it a scalar quantity or a vector quantity? It is a scalar quantity. If you ask me a question, right? Now I have a question. It has direction. Right? You can define the direction of electric current. What is it? So current flows from higher to lower potential, or positive terminal to negative terminal. That is taken to be the conventional direction of current. See, I'm telling all these points because you already know it. Right? So when it has a direction, how can you call it as a scalar quantity? It has magnitude and direction. It doesn't follow vector laws of motion. Right? So that is the reason why we still call it as a scalar quantity. So are you able to understand? Now, if you take a conductor, right? Generally, when you take a conductor, all are wires, right? Metallic wires, what you see. And when you talk about the metallic wires, generally they are in the shape of a cylinder, right? So if you try to see the zoom version of it, what is going to be present inside? Why do we use metals as conductors? Why can't we use non-metals? Because non-metals are obviously going to act as insulators. Why is it so? Because they do not have an important element present inside called as free electrons. So what do those free electrons do? So free electrons are the ones which participate in the conduction process, right? It is because of the transfer of energy happening among themselves, we are able to generate something called as electric current. Now the question is, you have free electrons inside it accepted. But are these free electrons going to be at rest, or will they be in motion? They'll be in motion. So when you buy a conductor, okay, let's say you're going to a shop, getting a copper wire and coming. Are you trying to say inside the electrons are already in motion? Think about it. Is it going to be in motion or not? But just now you told it is in motion. Only when you apply potential. But what happens in reality is the temperature is there, no? Which it gets from the surrounding. The temperature itself is enough to put these charged particles in motion. But the question is, since they are in motion, can I say current is constituted in it? I cannot call it because they are going to have random motion. Are you able to understand? They'll have random motion in such a way that all the velocity vector components will get cancelled. So still the net velocity is going to be zero. When can you generate current through them? Only when you bring an aligned motion to it, right? So what is happening inside is this electron, let's say it has velocity u1 vector, this will have u2 vector, this will have u3 vector, so on. It keeps on happening. Let's say there are n number of electrons in it. All those n electrons will have random motion. Like I didn't draw the arrow mark in the aligned direction, right? Now the question is, we understood what is electric current. If you are able to calculate, if you take any cross-sectional area of this conductor, if you are able to calculate the number of electrons crossing this charge, crossing this area, and you divide it with time, you call it as electric current. Okay, accepted. Now here also electrons are moving, right? But you cannot take it into consideration because they are not an aligned path. Now think is, how can I make them attain a fixed direction of motion? By connecting it to a battery or a cell. So when I do that, what is going to happen? Can I say there is going to be potential difference that is applied across the ends of this conductor, right? So this is going to be positive terminal and this is going to be negative terminal. Let's try to answer it in a more mature way. See, I understand potential difference, yes, it is helping us to make the charges. But from the knowledge that we have gained from the previous two chapters, there is one more important parameter that is there. So if any particle in this world has to move, okay, what you need to do? You need to apply force. Now the question is, you are saying potential difference there, but is the potential difference the one responsible for the force acting on these electrons? Think about it. Is the potential difference the one which is creating the force on the charged particles to move in an aligned path? Is it right or wrong? Then what are they? Then what is making these charged particles move in an aligned path? Gravity. It is horizontal. Why would gravity act? What are you able to see here? We know this concept, right? Electric field and potential are related concepts. E is equal to minus dV by dr. Means you need to remember this going forward. Wherever you see potential difference is applied, in the back end, what is getting created? Electric field is getting created. So when electric field is getting created in this direction, what would be the direction of motion of these electrons? So electrons will start moving from negative to positive. Listen to my question carefully. Electric field is from higher to lower potential. That is the first concept that we know. Secondly, charged. So in the presence of uniform electrons, in which direction do they tend to move? And they experience a force equal to E into capital E, where small e is the that is generated due to this potential. Is that clear? Right. So if you see inside a conductor, especially inside a metallic conductor, what are the major charge carriers? What do you mean by charge carriers? Charge carriers are the ones which are responsible for conduction. So when these electrons are going to move in the opposite direction, then this is the actual motion of charges, right? So if someone asks you what is the actual motion of charges, what will you say? It is from lower to higher potential, but the conventional direction of current is taken to be positive to negative because they wanted to create a similarity between all types of current. Here you're talking about electric current. If you talk about heat current, what would you say? It goes from higher temperature to lower temperature, right? To create that kind of similarity, they gave a conventional direction. So you should not get misguided thinking that positive charges are moving inside the conductor. No, what are moving inside? It is still electrons only. The electrons are moving in opposite direction. So conventional direction is taken to be the direction opposite to that of electrons. So conventional direction of current is opposite to electron flow. Conventional direction of current is opposite to the direction of electron flow. Make a note of this. guys? Right. So sometimes what do they call these electrons inside a conductor as? They call them as charge carriers. That is one technical word that is used. So charge carriers. So what are the major charge carriers inside a metallic conductor? They are free electrons. Okay. Charge carriers are free electrons. Is it clear, guys? Having this in mind, okay, let us try to derive one important expression. So here generally the first term that you are supposed to know is current and the second is potential difference, but we have already discussed potential difference in previous chapter. What is it? It is the amount of work done to move a charge from infinity to some point. We have already discussed all those things. That is why it is listed here. So try to understand, if I call this point as A and this point as B, this point has a potential VA and this point has a potential VB, then what is the potential difference B equal to? B equal to VA minus VB. So going forward, whenever I write B, right? So this is what you need to have in your mind. The more technical word for this is called as terminal voltage. So why we call it as terminal voltage? Voltage generally means potential difference. Why do we call it as terminal? Is because it is the difference between the positive terminal and the negative terminal. Is that clear? So anyways, this terminal voltage will not use it in this context. We'll still call it as potential difference. But the back end meaning of it is VA minus VB. I want you to have this clear mind. Is it clear? So yeah. So I'm going to derive an expression now, and at the end of it, I'll give a topic for it. So leave some space for the heading. Leave some space for the heading, and then concentrate on this. So tell me one thing, are you clear when potential difference is applied, electric field is created due to electric field, charged particles experience force. So when any particle experiences force, can I say it is undergoing acceleration? According to Newton's second law, F is equal to ma. If there is a non-zero force acting on a system, I can say acceleration is also non-zero, accepted, right? So can I say that these electrons are going to get accelerated in which direction? In the direction opposite to the electric field. Okay. Now, if I take the conductor, so this is before the potential source is connected. So this is before the potential source is connected. I'm summing all these things. Okay. So you don't have any terminal voltage. So as soon as you connect the terminal voltage, that is a potential source, what will happen? The electrons start moving in this way. Correct? Plus, minus, direction of electric. Now, the question that we need to ask is, what is the acceleration experienced by these electrons in terms of magnitude? What is the acceleration experienced by these electrons? So you know that F is equal to ma. So what is the force experienced by a charged particle due to electric field? F is equal to Q into E. Accepted? So this will be equal to mass into acceleration, which implies A is equal to E into capital E divided by M. This is in terms of magnitude. Whereas if I write it in terms of vector quantity, A vector will be equal to minus E into E vector divided by M. Is it right? Because acceleration and electric field are in opposite directions. Right? So let me call this as equation number 1. Clear, guys?
Sir, could you explain this again?
Sorry, ma. Can you ask the question again?
Sir, I got disconnected. Could you explain this again?
Which one?
After you have written force is equal to mass in MA.
From there, see.
Force is equal to mass into acceleration. This is according to Newton's second law. But force according to electrostatics is Q into E. So in the base, Q is charge of an electron. So electron is taken here. And E is electric field E into capital E is equal to mass and acceleration is still the same. That F is the mass of electron and A is the acceleration of electron. So A will be equal to small e into capital E divided by M in terms of scalar quantity. Whereas when you write it in terms of vector quantity, acceleration and electric field are in opposite direction. That's why it's the minus. Is it clear?
Yes, sir.
Okay. Now, so if I look at this diagram, right, I told you one point at the beginning. What did I tell you? That u1 vector plus u2 vector plus so on till un vector. Okay. If you divide these values with n, what do I call this parameters? What do I call this quantity as? So it is the vector sum of all the initial velocities. I repeat, vector sum of all the initial velocity divided by the total number of electrons. Can I call this as average initial velocity? Yes or no? So can we call this as average initial velocity? That is, before you connected the battery, this is what happened, right? But before you connect the battery, logically, what should not be present? Current should not be present. If current should not be present, then what should be the mathematical value of this average initial velocity? It should be a zero, right? Clear? Is it clear? Now, as soon as this electric field is connected, as soon as the battery is connected, right, can I say each electron is going to attain a final velocity? So I call this as E1 is equal to U1 plus AT or AT1. If you observe, I didn't write it as A1 T1. Can someone tell me what the logic was? Because acceleration of all the electrons is a constant. Electric field is the same, G is same, and F is same. So E1 will be equal to U1 plus T1, but write it in the vector form. Similarly, what about the value of V2? Correct. So what will be the velocity of the nth charge particle? It will be un vector plus a vector into tn. Accepted? Right. Now, if I add all these values, what will I get? v1 vector plus v2 vector plus so on plus vn vector is equal to how much? u1 vector plus u2 vector plus so on till un vector plus what can I take for common? A vector into t1 plus t2 plus so on plus tn. Correct? So I suggest you guys write it along with me. Okay, is this step clear? Now what I need to do is, I have u1 vector plus u2 vector plus so on till un vector, but what do I have here? I have u1 vector plus u2 vector plus so on till un vector divided by capital N. So for me to get a capital N on the other side, what do I need to do? Obviously, divide it with capital N on both the sides. Okay. So when you do that, what are you going to get? v1 vector plus v2 vector plus so on till vn vector divided by capital N is equal to, what will you get, guys? u1 vector plus u2 vector plus so on till un vector divided by capital N plus, what is the acceleration formula? Minus, and then I have substituted here minus e into capital E divided by m into t1 plus t2 plus so on till tn divided by n. Is there any doubt? So I just divided with n on both the sides. Clear this? So dividing with n on both the sides is what you get. So what will be the parameter that will disappear? So average of initial velocities will disappear. Can I rub this? Can I write it this way? Can I rub this whole diagram? Yes. So let's say v1 vector plus v2 vector plus so on till vn vector divided by t is equal to this quantity as 0. So what will you be left out with? Minus e to capital E divided by m into, you will have t1 plus t2 plus so on till tn. Yeah, tell me. Oh, sorry. So it is capital, right? Now you see, what will you call this as? See, first when you observe this, it is average of something. Average of what? Final velocity. So there is a name given to this called as V. V is velocity. V stands for drift. So this average of final velocities is given a name called as drift velocity. Is it clear? So drift velocity is equal to minus E into capital E divided by m into, what is the sum of all these values? What are you able to see from here? The average of all the time, right? So the average of all this time is given a name called as tau, where this tau is called as relaxation time. Okay. Right. So what will happen is Vd will be equal to minus E into E divided by m into tau. This is very, very important expression. So based on this expression only, we'll carry out the other derivation. Okay. So I told you, I tell you the heading, right? The heading is drift velocity of electrons inside a conductor. So this is the derivation for drift velocity of electrons inside a conductor. Okay. So you guys remember Ohm's law and all? V is equal to IR at constant temperature. Right? But you know how it has come? Why is it so? The answer to all those questions will be given by this drift velocity. So using this only, we will carry out the other derivation. Right? So major part of the derivation is covered in the first part of the chapter. Is it clear, guys? Right. So I'll stop with this. Okay. That's it. So any other doubts? Any other doubts on the concept? Yeah.
Why the formula for acceleration is negative?
Because of the different direction. The acceleration is the this direction, electric field is in opposite direction. So negative sign indicates opposite direction. Okay. So that's it from my side.
Those who are online, any doubt? Yeah, tell me.
Sir, will tomorrow's test be conducted online?
The paper will be uploaded in the app. Okay.
Okay,
If
sir.
you're writing from home, you need to write it and then go through the video that they would have shared how to upload the assignment. Upload it as a PDF within the deadline. Let's say the test is from 5 to 6, uploaded by 6:15. So the 10 minutes is only for you to scan and upload it. Is that
Okay,
clear?
sir.
Okay. So that's it, guys. Any other doubt? 1 minute.
Sir, tomorrow we should join the meeting or
Sorry?
we should join the meeting and write the test or
I didn't get you.
sir, tomorrow test is there. So we should join online or
No, see, if you can come and write it here, it is well and good. If not, if you're going to write it from home, you need to open the app, go to the assignments tab. From there, the question paper needs to be downloaded on your side. Okay, write the test in your notes and upload it back as PDF.
PDF will not be able to.
You need to
That's
download
study.
the PDF scanner or something.
Sir,
I'm
I
saying-
tried the study material.
No, it's not the study material. In under assignments itself, you'll get it. Okay, under assignments, you'll be able to upload it. Okay. You can go through the video that I shared. You'll be able to understand it.
Sir,
Yeah, tell me.
sir, what about the timing, sir?
5 to 6 only during class. Sir.
Okay, sir.
Okay. Yeah. So any other doubt, guys? That's it, right? Is that all?
No doubt.
Okay, we'll wind up.
Thank you.